Now that we understand how hardware-supported protection levels can be used, we can start explaining how virtualization techniques can be developed that achieve their goal to efficiently, at near-native speeds, allow execution of virtual machines on top of these basically identical virtual platforms. First, guest instructions are executed directly by the hardware. That's an important thing to know. The virtual machine monitor does not interfere with every single instruction that is issued by the guest operating system, or its applications for that matter. What this means is that just like the OS doesn't interfere on every single instruction and memory access, here the hypervisor does not interpose itself on every single operation and every single memory access performed by the guest. As long as the guest operating system and its applications operate within the resources that were allocated to them by the hypervisor, then everything is safe. The instructions in those cases will operate at hardware speeds, and this will lead to efficiency of the virtualization solution. Whenever a privileged instruction gets accessed, then the processor causes a trap, and control is automatically switched to the most privileged level, so to the hypervisor. At this point, the hypervisor can determine whether the operation is to be allowed or not. If the operation is an illegal operation and it shouldn't be allowed, then the hypervisor can perform some action like to terminate the VM. If the operation should be allowed, however, it's a legal operation, in that case, the hypervisor should perform the necessary emulation so that the guest operating system is under the impression that it actually does have control over the hardware. So from the guest perspective, it should seem as if the hardware did exactly what it was expected to do given the instruction. In reality, however, it was the hypervisor that intervened, that potentially executed a slightly different set of operations in order to achieve that emulation. This trap and emulate mechanism is a key method on which virtualization solutions rely in order to achieve efficient CPU virtualization.